Hello and welcome back. This is a quick video solution for day 11 Advent of Code 2023. The problem states that you are given this grid, and in this grid there are some hashes and dots. Dots are the empty spaces through which you can traverse, and hashes will be the starting positions for which you need to find the nearest hash. So in this question you are basically asked to convert this input grid. So this will be the input, and you need to convert this first of all to this one, which states that you need to convert any empty row to by adding one more empty row just below it. So as you can see, this was the empty row and this is present as it is, and one more copy of it is added. And the problem states that you can basically add m copies for the last test case. These m is up to 10 to 6, and for the part A, m is 2. So for every row where we find a empty row of all dots, we take it m times. This is the question, and you need to do the same thing for any column. So if you observe this column right here, it has all the dots, and this is repeated twice at these two locations. So m times it is repeated. After this grid is formed, this is the grid that you need to work on, and in this grid for each hash you need to find the distance to its nearest, shortest distance from this hash to all the other hashes. And let's say there are k hashes, then you need to find the distance, sum of distance of shortest distance between all of them. So let's say shortest distance is SD from I to J, and there will be these many pairs for which you need to find out this sum. Let's try to look at some of the observations. So as we saw, let's say this hash is numbered 5 and this is numbered 9, then this is one of the path that we can traverse as denoted in this. And one thing to note here is that there are no obstacles, because there are 4 possible movements that are allowed to us from any cell to its neighboring adjacent cell. So this would be, let's say from I to J, we are moving to I to J plus 1, or I plus 1 to J, I minus 1 to J, or I J minus 1. These are the 4 choices that are available to us to traverse from current node IJ. And there is no restriction on whether any cell is bound to be closed or not available for traversing. There is no such condition, hence there is no observation, and basically we can traverse any path like so, and it is always the minimum path. So if you traverse this path, it will give us the minimum distance between these two hashes, and the minimum distance for these two hashes would be given by, let's say, from I1 J1 to I2 J2 as the Manhattan distance between those 2 points. And it is I1 minus I2 plus J1 minus J2. This would be what we need to find out for all the pairs. Summation over all the pairs of hashes. But one thing to note here is, before finding out this thing, these hashes will have a different coordinate once this shift has been performed, right? This is the shifting of hashes. So initially this hash was at 0, 3, but now it is at 0, 4, because one extra row would be added, extra column would be added here. So to find out, so if we have all the coordinates of this hashes, then it is easy to find out the whatever is asked in the question by applying this formula. But to find out the new hashes after the grid is transformed, you need to do some of the transformations. To do that, first of all, let's try to take this example. Let's say there was a hash here, and you need to know how far it will be shifted to the right and how far it will be shifted down, so that it will end up at this position in the final grid. Now this amount of shifts would be the number of empty columns, right? So if there is a empty column here, and let's say the multiplication factor is m, then let's say there are 3 empty columns here, then this shift from I to j would be I to j plus the number of new columns that would be added would be, let's say 3 were then, and each of them will add more m columns into this. So there was an empty column here, this was already present, but now the transformation will add m minus 1 columns here, m minus 1 columns here, and again in this region. So this region will have m minus 1 new columns, hence 3 times 1 2 3, 3 times m minus 1 would be the new column coordinate. And similar for the row, we need to find out how many empty rows were present before this. Let's say this was 6. In that case, this I comma j would have transformed to I plus 6 times. Each empty row will add m minus 1 new empty rows. Hence the coordinate would be 6 times m minus 1, this thing. Hence the overall from I to j, we will go to I plus some new added columns, new added rows, and j plus new added columns. And once we find out these coordinates for all of the hashes, we can apply the same algorithm as we saw to find out the minimum distance between all the pairs using Manhattan distance. Now let's look at the implementation. Okay, I have some of the constraints. This keeps track of whether a particular row is empty or not. So e row of a particular ith row would be true if this row is empty. So let's say it was something like this: 0 1, then e row of 1 would be true. This is what the information will be stored. Similar for column, we will do it the same. We will find this out as soon as we take the input. So I will take input as string from each line. I will create this matrix in which I will be storing the n cross m characters. And after if I check that this row is empty, then I will say that this is true. After finding out all the rows, I will traverse through all the columns, and to check the values in this column, I will create a string which is the values that are present in the column from top to bottom, check whether all of them are dot, This denotes we found an empty column, and we can initialize that variable as true. Next, we need to do this for all multiplication factor. For part 1, we have m equals to 2. So this was the multiplication factor. Basically, we add one more row for every empty row and one more column for every empty column, and this was for the part B. Part 2. And to do this, we will first of all find out all the hashes, the locations of all the actual coordinates of those hashes. Notice that we haven't added any new rows or columns as such while taking the input. We are taking the grid as raw and first of all finding out all the coordinates. Now this new coordinates of all those hashes would be found out by traversing the rows behind it and columns above it, and each time we find a empty row, for that we saw that m minus 1 new columns or new rows would be added. Each time empty row is found, empty row or column is found and counted. And this is how we'll end up by updating all the coordinates in this hashes with their actual coordinates in the final grid, and after that we will find out the pairwise distance between all of them. So I coordinate with j coordinate and taking the sum of the Manhattan distance between them. This will basically count this twice, I to j and j to I, but we are only allowed to do it once. Hence I will assure that we have even number of we have counted it even number of times, that is twice each of them. Hence the answer would be divided by 2 at the end, and we'll print the answer at the end. That is what this is about. And the solution that I solved in the live stream was very unoptimal. I essentially constructed the entire grid for m equals to 2. Then I performed a BFS which started from every starting cell. Then we keep on trying for all of the cell, and after that we get the shortest distances to all the hashes, and which was very unoptimal. But eventually I figured out that there are no obstacles, and distance between any two cells would be given by their Manhattan distance. As this observation was very helpful for that, and this is how the solution is approached. That's it for this video. If you have found this helpful, or if you have any doubts or suggestions, do let me know in the comments. Thank you.